Hello there, Algebra 2B. Welcome to Lesson 7.2, Part 3. How are the properties of rational exponents related to those of integer exponents? And today, we are going to be adding and subtracting our radicals. Now, it's just like adding like terms, okay? So, for example, if you have 3x's plus 5x's, you have a total of 8x's. When we add square roots, if you have the same square root, exactly the same. So square root of 2 and 5 square roots of 2, 3 of them plus 5 of them is 8 square roots of 2. But they have to be the same root. So for our first example, it's pretty easy. So we have the fourth root of 10 and the seventh fourth root of 10. So really this is like one of them plus another one. Again, if these are exactly the same, then you can just add them together and make 8 fourth roots of 10. That's it. That's the answer. Boom. Done. Okay? So it has to be exactly the same. Another example here. Remember that exponents, you need to constantly be remembering that these are the same thing as radicals. This is really the third root of x squared, and same with this one. Okay? So we really have the same root, they're just disguised. So essentially we have 2x to the 2/3 plus 7x to the 2/3. You might also see it like this, okay, without the parentheses, and it really means the same thing. So recognizing our base, and that just means we have 9x to the 2/3, okay? You don't need those parentheses. If you want to keep them in there, you can. But that is the answer. All done. So same exact radicals can be added. Okay. Also the same. So this is just another example. So fifth roots, that's our base, that's our power. So we have 9 fifth roots to the 1/5. Here it probably is a little more important to have the parentheses. That way I don't think it's a 95. So this time include the parentheses or so. But that's really the name of the game. Okay? Where it gets a little more challenging is whenever it doesn't look like they can be added off the bat. So here we have 4 through to 48, 4 through to 3. Right now, can't add them together, okay? But you need to look for the secret identity. It's secret identity. Like Superman, Batman. So this is where you need to know how to break that down. So we're going to use the calculator trick. 48 divided by x to the 4th. Okay, we're going to go to the table, and lo and behold, we can realize that that's the same thing as 2 fourth roots of 3. Now that they are the same, okay, we can add them together. That's really one of them. So we have 3 fourth roots of 3. What do you know? So always be on the lookout for secret identities. Okay. The same thing works with subtraction. So we haven't done a subtraction one just yet. But if this happened to be minus, okay, we would have 2 minus 1, which would then just be 1 fourth root of 3. Okay, so subtraction is really the same idea. Speaking of subtraction, let's check out this one. Now there's an extra little curveball with this one. So the 4 out front, you have to remember is being multiplied. The third root of 54, we're going to use the calculator trick with. So third root, 54, divided by x to the 3rd. Table tells us it's really 3 roots of 2. So 3 cubic roots of 2 minus another cubic root of 2. Now, here is the kicker, okay? You are multiplying these together. 4 times 3. Sometimes students want to add. Sometimes they want to do something else. It's 12 total roots of 2. Okay, so then minus the root of 2, which then becomes 11 cubic roots of 2. So coefficients out front, multiply after. So you have to multiply and then get the 12 and then subtract. So that's really the name of the game. If you happen to have something with variables, really the same story. Okay, so 12 cubic roots of 2x, cubic root of 54x. We have a secret identity with this one. So fortunately, we just did 54, right? Yes, we did. So it's really minus the third root of 2, 3 third roots of 2. And we have 12 to x. Sorry about that. 12 cubic roots of 2x. Don't let the extra variable scare you. As long as those are exactly the same and exactly the same index, you can add them together. So 12 minus 3 is going to be 9 cubic roots of 2x. Okay, one last thing. Okay, so that's addition, subtraction. Let's say with this example, we added a third root of 3x. Okay, so we're going to add a third root of 3x to the mix. Well, since those are not the same, you're just going to have an additional third root of 3x at the end. Okay, so even though they are both cubic roots, they cannot combine together. Same thing if we happen to add like a fourth root or something. So the indexes have to be the same. Even though this is a fourth root of 2x, it's still not the same. So you cannot combine them if they are different indexes. Okay, this is 4, and you can't combine them if they are different things inside. Okay, so just be aware of that. Remember, multiply numbers out front